Good morning, everyone, once again. A very warm welcome to our bootcamp. Today, our session is on AI agents. AI agents is the culmination of our course on advanced prompting techniques. The word in AI, the word AI agent has been fairly long aspiration of people for quite some time. People in the community have tried to create uh, there's a vast amount of theory around AI agents that people have developed. And so one second, let me bring the window to the right place. Where is the window? What is happening here? Okay. So here's a little bit of a history of this field. If you pick up a textbook on AI, you will notice that the theory of AI agents, a topic called AI agents, dates back many decades. You see development since the 1980s to the early 90s. In those years, much of the theory of AI agents was based on, or was thought to be based on, reinforcement learning. Reinforcement learning, just to whet your recollection, is a form of machine learning in which you teach a machine not by giving it explicit training data, but by giving it a goal. And you give it a reward and punishment. You have a rewarding policy, and so you create some sort of a gradient based on how good its internal policy is action is. And basically, it proposes an action, does it? And as it does, if the action is good, you reward it. If it isn't, you sort of reward it less, or you punish it. It's a carrot and stick form of learning. And using that, the machine eventually becomes very, very good at it. Reinforcement learning has had remarkable success, but its main issue has been that the compute time taken is prohibitively long. It's very, very long amount of compute, a large amount of compute it takes for reinforcement learning. Situation has been getting better. The theory has been evolving. But nevertheless, of all the forms of machine learning, like supervised learning, unsupervised learning, reinforcement learning, supervised learning and which is predictive analysis, and unsupervised learning, which is pattern recognition, have had far more application for many decades in real world problems than reinforcement learning has had. Now, what are AI agents? How is it that the AI community thinks of AI agents? They have always thought that the core or the dream of AI is to create AI agents. Agents would be things that have access to tools. They have sensors. They engage with the external environment, right? So, for example, they don't just solve a math problem for you. 2 + 2 is 4, something like that. Or solve a quadratic equation if you give it. Instead, what they can do is they can take in inputs from the external environment. They have sensors to sense the external environments. And based on the events in the external environment, they can think, they can reason, they can come upon a plan, and then they can act upon that by proposing certain actions and doing it. So for example, a very easy example of that would be, let us say that the AI agent is observing the camera, which is the outside of your house. And let us say that in the camera, it recognizes that it is you coming there to your home. Let's say hypothetically. And so the AI agent may decide that now that you're coming, it can walk over to the door, perhaps with a glass of water, and open the door for you and welcome you inside. Right? That would be agentic. That would be very much an AI agent at play. So if you look at this very simple scenario, you do have an agent ability to sense things in the external environment, namely that you have showed up by looking at the camera. Camera is the sensor. They're bringing in the inputs. AI agent is the intelligence that figures out, now, what do I do? What does this input mean? Right? What does it mean that I have seen a person in the camera, right, approaching the door? It makes sense of it. It does pattern recognition, or it does recognition that it's you. And thereafter, it plans and comes up with a course of action. It knows that you like to have water as soon as you come home, full water. So it might walk over to the fridge, take water, and then walk over to the door and then say, well, welcome, and open the door for you. Now, this is sort of while it looks simple, actually, it's a little bit hard to make it happen. It is only now that these agentic systems are beginning to come alive and happen. Autonomous agents are beginning to happen. So when it does something, for example, it opens the door, it goes to the refrigerator, picks up water, and does things like that. These are actions, these are actuators. It has to have actuators too, hands to go and pick it up, tools to go pick it up. And so today, when we look at the world of AI agents, our first reaction often has been robotics, right? AI agents as robots. And that is certainly one very big way. But remember, at the end of the day, robots are more sensors and actuators. You still need the brain in there. And the brain has been the core area of research. That is the core problem in artificial intelligence that we try to solve. Now, the way that this AI agents theory has intersected with prompting or large language models is in a very interesting way, actually. One of the realizations as these large language models came about was that these large language models, to the extent that they understand language and to the extent that they have some reasoning capability and some planning capability, you could use these large language models as agents. And how do you engage with the large language models? You engage with the large language models through prompts, isn't it? That's your typical, the input you call prompt, the output you call continuation, more formally, or just the output of that. So the whole question is, if we can train these large language models and to reason and to act upon input and output. And nowadays, the sensors and actuators, we sort of amalgamate all of that and just call it tools. Right? So a precursor to this was the paper, a research paper, which we covered in this course, namely REACT, Reason and Act. Reason and Act was that a machine could reason and say, I need to do this, and then have access to a tool using which it could act. You see that, right? You see the beginnings of the way agentic reasoning, agentic action coming there. And the theory has developed much beyond that. These are the early works, and people often in the formal literature often call it the zero gradient agents. The reason they call it zero gradient agents is because you have built it out of LLMs and prompts. You don't have the full benefit or the full infrastructure or architecture of reinforcement learning. The LLM, of course, itself has gone through some reinforcement learning, but when you build AI agents, all you're doing is you're using a form of prompt engineering. And that's what helps you create an AI agent de facto. That is a remarkable breakthrough, actually. The fact that you can do that, the fact that you can create agents, and therefore the big explosion of research papers and companies and open source projects, startups and open source projects, all centered around so-called LLM agents that you see happening today. I would say that just as 2023 was the year of chatbots and RAG, 2024 is the year of agentic reasoning, AI agents. And 2025 is when this will all become very, very real. The amount of energy that is being spent on the development of AI agent systems is just phenomenal. There is absolutely no doubt in anyone's mind that this is going to be a significant part of the future, the AI agents. Are we together?
So my question is like AI agents plus robots, when are we going to see robots taking the trash out?
When are you going to see the robots take the trash out? Actually, if you are there in the next version of the AI agents class, you will see it happen right here. I mean it. Yeah, you will be creating AI systems that will reason and say, oh, today is Thursday. Tonight is a trash day. So let me take the trash out. And when will they be able to cook? Actually, believe it or not, those things are already in the works. They are beyond research. They are being productionized. They are being productionized.
Is that for the consumer or?
Yes, for consumers, it is all coming. So, guys, do you remember? So, there is a bit of a dystopic aspect also to AI agents, since you guys brought it up. How many of you have seen the movie Stepford Moms or Stepford Wives? You haven't. You haven't seen Stepford Wives. Okay. It's a very old story, a movie, which I actually, in the context of AI agents, may I give it as a homework assignment? Go watch Stepford Wives. Seriously, or at least watch. It must be there on Netflix or Prime, or one of you can please look it up where it is. But Stepford Wife actually does form a good backdrop to this. So the story is of a dystopia. The men, being men, they want perfect wives, and human wives are obviously not quite perfect, right? They argue back. They don't always do what you want them to do. So what they do is they create these autonomous robotic wives that look exactly like their wives. And then they take their wives on a vacation to, I don't know the full story, but it's been a long time I saw that movie, but you just take them to a little, I don't know, commune or something like that. And you leave your wife there. But, and they live, the real human life, wives spend their life happily ever after in some form of containment. Oh, and the husband brings back this Stepford wife, right? Who is absolutely obedient and does everything that you say it does, right? So that's a dystopic view of AI agents. So, well, since Vasudev, since you asked this question, it has already been thought of many, many years ago. When it will become a reality, nobody knows. We are not there yet. To, I suppose, the great disappointment of a lot of men. Well, the converse can also be true, right? Stepford hubbies. Yeah, certainly, yes. The latter is more likely to happen. Anyway, so we are going to talk about AI agents. It's a very, very important topic, and it is a good culmination of our advanced prompt engineering course. Now, in this prompt engineering course, if you see, we evolved. We already went to the level of open function calling, right? And the use of tools. Did we do that last time? And I have been emphasizing that we are encroaching upon the territory of AI agents, right? Planning, use of tools, calling functions. These are actually, today we consider the core domain of AI agents. So I'll culminate today by giving you this thing on AI agents. I must also say that I offer a course in AI agents, which takes what is today an introduction. It takes it far, far deeper, really deep. We build more systems. Actually, we didn't go as deep as I would have wanted to because of somewhat budgetary constraints. The robot that Vasanthi has been dreaming of was going to be purchased, but didn't show up because I couldn't purchase it. Okay, so maybe for next time. But whenever it happens, so when you guys come second time around, you'll be luckier. And Prasanna, of course, you're welcome to the second iteration also. Remember that registration to the course is forever. Any course is forever. So what really are AI agents? Let's think about it. I give you a very basic introduction to AI agents. Now, let's delve a little bit more into it. So when you think of AI agents, how many of you remember, at least if you don't remember Stepford Wives, you remember Matrix? How many of you have seen the movie Matrix? All of us have, right? Sukhpal, you haven't seen Matrix? You have, right? You also. You have not seen Matrix. Okay, homework assignment number 2. Please see Matrix. You have to see Matrix. But do you remember that it was filled with autonomous AI agents? Isn't it? So,
Agent Smith.
Agent Smith, yes. So you have AI agents, and the interesting thing is, a matrix is actually a good way to go into the topic of AI agents. What do you notice? All those autonomous AI agents, they have certain degree of autonomy, but they are all working in coordination. They have a goal. They work towards a common goal. They form teams, and the team has a goal. isn't it? Do we remember the movie Matrix? So that is something that I want you to remember. That, see, when we think of AI agents, there is a lot of confusion in the literature and in the YouTube and on, in the discourse that's happening. Two things define the zeitgeist. First is everybody is excited about AI agents. And the second is, it's like the Tower of Babel. Everybody's definition of what AI agents is different and has a different notion of what AI agents is. So the first thing we will do is we will form a consensus on what exactly are AI agents. Let's do so. So here is how I would define AI agents. AI agents are autonomous pieces of intelligence, each AI agent, but the power of AI agent comes not from the fact that you have one AI agent with certain degree of autonomy. It comes from actually two different aspects. It comes from the fact, because if you just have one agent with autonomy, that is nothing but a prompt. Today, you can have a ChatGPT. You can engage in a conversation with GPT-4 or Gemini or Anthropic and see quite a bit of agentic behavior. What makes the picture actually quite confusing is the fact that these frontier models and their companies, they have been encroaching into the AI agent territory, and they have been obviously incorporating a lot of agentic reasoning. So I would say that if you think back to what those GPTs were or Anthropics were, Cloud was a year ago, that's a more fair picture. But you can recover a lot of the functionality of the AI agents in a single agent, but that's not where the power is, because that you could do with the prompting that you have learned so far. Little bit of agents there, but the power of agent comes from something different. It comes from two things, and this is important. This is how I reason about it. And I'll give you a little bit of an autobiographical statement. Here at Support Vectors, we tried to do AI agents. As we did AI agents, in the beginning, our approach was the approach of everybody else. We had all of us have taken artificial intelligence courses in our graduate school and our undergraduates and so forth, and so on and so forth. I had, and computer vision courses and so forth. Nevertheless, when LLM as AI agents came up into the scene, or the so-called zero gradient without reinforcement learning, it was a new approach for everyone. We started playing with things. In the beginning was the so-called what was it? AutoGPT, which is a single agent with some tools. Then came AutoGen, finally came Creo AI. We picked up, we are now, as of this moment, and then came LangGraph and now BERT, and some other tools began to come. But we are very fond of Creo AI. We standardized on Creo AI. And you'll see why we standardized on Creo AI eventually. But our experience was very interesting. And I think this is a universal, there's something universal about the experience we went through, or the learning curve that we went through. When we started using LLM as agents, for quite some time, we scratched our head, and within the team, we kept saying, so what is this? What is this? It is nothing but prompt, right? It is just a fancy dressed up prompt. So what is the big deal about AI agents, right? Isn't it just marketing hype? It is reminiscent of a time when statisticians used to say that machine learning is nothing but statistics wearing a marketing hat, right? This is, for example, I think Professor Pipshirani here at Stanford, he came up with a famous slide, famous and somewhat notorious slide, in which he said that if you have a statistics conference, the budget will be, say, 10, 20,000. If you change the title to machine learning, the budget of the conference suddenly becomes hundreds of thousands of millions. Every company is pouring money into it and sponsoring it and so forth. So in a similar vein, people began to say that if you are prompting, just say you're doing AI agents, and then suddenly it will just sound very happy. And so we started with actually a misconception like that. And yet, fortunately, we slogged on, we persisted, we tried to work with this. But we benefited also from the fact that we are imbued with a lot of AI agent theory coming from a prior textbooks and so on and so forth. So we hope that we can do a lot. It took me personally a month of coding before it finally dawned on me what the real power of AI agents was. What is it that you can do with AI agents, and what is the right, what I would consider from my point of view, and this is a bit subjective, how should you approach the topic of AI agents? Like I said, AI agents, despite being an objective topic, at this moment suffers from the fact that everybody has their own understanding of what AI agents are. So what I'm conveying to you is how we understand AI agents. And this is how we understand. I feel that the power of AI agent comes from two things. Team. The AI agent is a team effort. Are we together? Power of AI agents is only there when you create a high-powered team. It's a team sport. Think of AI agents as playing a team sport, like soccer, like baseball, like anything, right? It's a team sport. The second source of AI agents' power is obviously the sensors and the actuators, the actual tools that they have access to. The richer the arsenal of tools, the more powerful your agentic systems will be. Now, this mirrors real life. The power of any tribe, for example, depends upon how much of cohesion and unity and cooperation and coordination there is in the tribe. At the same time, it also depends on the technological prowess of that tribe. What tools, what things it has access to. Can it light up a fire to cook food? Can it defend itself? Does it have wheels to carry things around? And transportation and so forth. So it's the tooling that enables, empowers a tribe, for example, of human beings. The same is true for AI agents. And so looking at it from that perspective, here is how I would say, I will first focus on the team part of it. What is a team? Just going back to the roots, and sorry for a small digression. So a team, the definition of a team is a group of entities rooting for a common goal. And notice the word, I've replaced the word people with entities, because now it turns out that AI agents are also like people. So I said a team is a group of entities rooting for a common goal. And so give a team a common goal to accomplish. That's what makes it a highly effective. So true for biological teams as well as for AI agents. In terms of game theory, and there's a little bit of a game theory that is applicable here. If you think in terms of game theory, you have cooperative games and adversarial games, zero-sum games. Chess is it a cooperative game? A zero-sum, it's adversarial, it's a zero-sum game, right? The only way I can win is if I topple your king, right? So on the other hand, a team inherently plays a cooperative game. If they accomplish the goal, they accomplish because they all collaborate and cooperate with each other. Even when two teams compete, you may be competing with the other team, but within the team, all the team members are playing a cooperative game, isn't it? For example, if it is soccer, I'll pass the ball to you and you, because you are close to the goal, right? And then you can shoot it into the goal. I don't try to shoot it straight from far off into the goal, isn't it? So that's the main idea. And this picture, I put it here because many of you know, rowing. Rowing is a classic team sport. If you row well as a team, you shoot like an arrow. It needs coordination, perfect coordination, right? Timing, and it needs perfect execution. So this part I can't emphasize enough, because, by the way, guys, when I say this, it is not theoretical. When you write the code, when you do the project, you will notice that it will mean something real in your code, the code that you write and the agents that you create. What mechanisms that you have put in place to ensure complete cooperation. We'll talk about it. When you have highly effective teams, then, and researchers have been speculating about this for a very long time. And the beautiful thing is I have seen every time you see this in your agentic systems, it is a marvel, right? It is emergent behaviors. You see, have you seen the scene over rural landscapes? For example, if you're driving over the Central Valley of California on Route 5, Interstate 5, this must be a very common scene. I hope all of you have encountered this. right? Or if you come like me, go to the bay, as I do every morning on the hike, I find not every day, but on some rare days, you do see a scene somewhat similar to that. These birds are forming these beautiful patterns in the sky. It's an emergent phenomenon, isn't it? Now, notice that it is not that the birds are all talking to each other and saying, you move here and I'll move there and we'll form this pattern. They're still autonomous birds, but because they have certain common rules of behavior and cooperation, this beautiful patterns sort of emerge from that common behavior. Right? And in my case, I don't see something like this. I usually see flocks of geese going on, and they form sort of V formations, and those V formations sort of keep changing. It's it's amazing. And actually, you notice it's quite interesting how they navigate the hills and so forth. So the potential of a good agentic system is that it can, given a chance, solve a complex problem through, and while solving it, it may exhibit emergent behavior. Now, this goes to the old theories, in my view, of scientific management. Now, those of you who have taken courses in management would remember that the old scientific management theory on which the factories and everything was based, all of us have taken it in our engineering courses, was that to be highly effective, you need a conveyor belt, factory floor mentality. You need specialization of labor, division of labor, and specialization. When you divide the task, one guy is good at welding and another guy is good at foundry. What does it do? That such specializations leads to excellence, centers of excellence. You can create specialized techniques in welding, and you can create specialized techniques in a foundry. Isn't it? So specialization is very important. When you create players in your AI system, important that they are very focused and well-articulated roles. They should know. Another analogy is that of an operating theater. If you see surgery in a theater, everybody knows their focus role. Anesthesiologist knows when and what the anesthesiologist has to do. Has to take the patient under, has to be monitoring for distress, has to be looking at the heart rate and the breathing, isn't it? Respiration rate. And the brain waves, and so forth, EKGs, EEGs, and so forth. The person who does the first incision knows that that's the role. The person who has to do later on, the resident who has to stitch up the patient at the very end of surgery, knows when that person's turn is going to come. The main surgeon knows when that she has to step in. When the main surgeon steps in, every single nurse knows which equipment to hand to the surgeon in which order. That is a classic example of specialization of labor and coordination, right? So the way I say it is each player has a very focused and well-articulated role. And the word that we use is a French word, raison d'être. Therefore, each player brings some unique or differentiated contribution that is absolutely essential to achieving the goal effectively. Right? If you cannot justify why you need this agent, if you can say that without this agent, your work can be done, your goal can be achieved, you don't need that agent. As simple as that. Are we clear, guys? Right? As you build a team of agents, be sure of that. This value, in my view, and I don't see it usually formulated like this, but I formulate it like this, that there was a mathematician named Shapley who actually got a Nobel Prize for a very simple idea. By the way, he was a friend of John Nash of the Nash Equilibria fame of game theory. John Nash of the, have you seen the movie Beautiful Mind? So yeah. So they were classmates, I believe, or friends. So anyway, Shapley answered one interesting question in game theory. Suppose a team achieves a goal. To the successful achievement of the goal, suppose you have a pot of money to divide, or you need to apportion credit. How much credit does each team member deserve for accomplishing the goal? How would you do that in a cooperative game? You see the problem, right? It is central. Otherwise, If you're not given enough compensation, you might not want to do much. You cannot divide it equally because some contribute more than others. Right? So the right apportioning of credit is a formula, mathematical formula, which roughly speaking, the intuition is what would the outcome have been without this player and what would be the outcome with the player. Now, you quantify that, and the difference is the Shapley value. Right? And so you need to make sure that each player has a non-zero Shapley value. Ask yourself, what would happen if I take this agent out of my code, disable this agent? Will the goal be achieved equally? Or more formally in our field, we call it ablation studies. What if I disable this piece of functionality? How degraded are the outcomes? Right? Those ablation studies are exactly the Shapley value, determining the Shapley value of your agents. Next is, you need to have flawless collaboration. We talked about that. So I'll move forward. A successful surgery is always a flawless collaboration. Everybody knows what will happen. See, good surgeries are boring surgeries in the sense that there are no surprises. Yeah, things happen exactly the way you had planned it to happen. And somebody said that that's true of mountaineering also. A great mountaineering expeditions are boring expeditions. There's no drama. So the same thing is true. So now, while these are the core patterns of team, let's go and look at the design patterns that are essential for agentic reasoning. So when I use the word agentic reasoning, broadly, I'm assuming that we are talking of multi-agent systems. The word often used is MAS. The abbreviation is MAS. Just like RAG is the abbreviation, you will hear the abbreviation MAS more and more in the coming year. MAS stands for multi-agent systems. And I will just assume that we are always talking of multi-agent systems. And so we'll look at the patterns of agentic reasoning for multi-agent systems, right? And I like this actually. As a physicist, you realize one way that I think about it is that, see, if you ever sit in the command center for NASA and they're about to launch something, there is a sequence that sometimes you see it in movies and this, that is actually real. Before a spaceship is launched or a rocket is launched, every division is asked, is it a go or no go? Right? It's a coordinated effort. Everybody has been working hard. If everything is done and finished and proper, then the lead of each division says a go. And that's how you make a go, no go decision, right? And then you have what people often call all systems go. Right? And you start the countdown sequence after that. So somewhat like that, that is one metaphor I always have with large-scale projects. And AI agents or agentic systems are good for large-scale problems, things that you don't want to do in one-shot prompting, right? So here we go, one pass prompting, giving it one input and then expecting an output. So first is planning, right? So let me, go to this. Planning is the first part. Planning means, given a complex project, you need to be able to think, what does it involve? To achieve a goal, again, remember, you have to have a goal. Given a goal, what are all the steps that you need to do to accomplish that? How would you go about it? It doesn't necessarily mean that you a priori establish all the steps. It could be exploratory. You may say, we don't know enough, but here is how we can find what it will take to solve the problem. That is a plan, right? Remember, I did not say lay out the steps or the subtask explicitly. And there are AI agentic systems that are coming up, which sort of a priori explicitly say, tell all the steps that are needed. I consider them to be somewhat weak. I would rather have a more general system, which says, well, that if you have to go to a goal, you should at least know how to start and figure it out, how to accomplish the goal. Am I making sense? Right? How to accomplish the goal. You need a plan, just that. And that subtlety is important. And with that plan, you need to divide it up into tasks that you can do. Now, once again, I would say those tasks do not necessarily mean that if you do all the tasks, you will get there. You'll start with a preliminary set of tasks. And as you do those, more tasks may emerge and get added. right? The team may decide that we need to do this too, and we need to do that too. So task decomposition is important. You do that. That's another core piece of the puzzle. Coordination between the agents is important. You need them to coordinate the way human beings. It is not a team if nobody is talking to each other. All of you know, all of you are senior management here, you know that you have spotted a dysfunction in a team when you see the communication has decreased, or one group of people in the team don't talk to the other group of the people, right? You don't have a team anymore. Right? You need, obviously, coordination and collaboration, they go hand in hand. But one of the most important parts of agentic reasoning is you need to exploit this AI's ability to self-critique and reflect on its work. I have been seeing this over and over again, and throughout this prompting course, we have done that. What is it that we have done? We always force the LLM to reflect upon the work it has done, isn't it? Self-reflection. Did we do exercises in self-reflection, guys? We did that. Did we? And along with it are ideas like a chain of density and so forth. You keep on making it better and better, right? So and it goes to the heart of the way AI today is, circa 2024. Our generative, even though we have generative models, discriminative powers in LLMs are stronger than generative powers. And in some sense, it is far more able to critique than to generate. So you can ask it to generate and critique itself, and then it will find all its faults, and then you ask it to fix itself. You can iterate. So that is critique and reflection. It is a very important part of agentic reasoning. It needs memory, right? So obviously, you need to have, just like a tribe or a family or something, whenever a team makes progress, we need to keep account of what is done and what is not done. You need memory associated with the team. You need memory at the level of the individual. You need memory at the level of the team. And of course, this hardly needs to be told. The power of agents comes from the tooling, just like the power of a tribe comes from this technological prowess. It's tooling. Right? What is the strength of the tooling that you have access to it? Now, here, I'll take a small digression and say something, guys. All of this, and I will introduce you to a AI agent framework today, Creo AI, because as I said, I tend to have a slight preference for it. Right? It's easy and it aligns with my way of thinking. You'll use the Creo AI. It comes with certain tooling, and it leverages the tooling that is there on LangChain because it rests upon LangChain. Nevertheless, when you build your system, take it as a given that you will create far more tools than you will just import and adopt from open source. Are we together? Because the more custom tools you home grow that is not there in the open source, the more powerful an agentic system you can create. Don't ever get into the misconception that the only tools you will use are the ones that come out of the box. Are we together? Go rich in tooling, Create very specific tooling. I'll give you an example. Obviously, I am into education and edutech. Right? I actually have a tooling that specifically checks whether a writer can prove. So suppose I have a person, so it is called cognitive maps. Suppose for an individual, I have a cognitive map that this person has learned this much, is good with coding, but at this moment still learning about the math and so on and so forth, right? Some aspects of it. We get it from the way people have answered the quizzes, for example. You can actually do AI, you can have a tool whose only judgment is to assess whether or not, given this background, this content is appropriate to the person or it needs more details, more explanations. Do you see how simple it is, right? It is very specific to the problem. Create very specific tools, always very specific tools. Sensors, well, of course, sensors is somewhat redundant because now tools captures all of that, but sensors is how it senses the external environment. So guys, this is the rubric. Prasanna here has taken the AI agents course. You would agree that this slide is perhaps the most important slide of the course, isn't it? Yeah. This is the rubric. If you just make sure that when you design your AI, your agentic systems, every single of these items has been, 8 items has been checked. You have accounted for all of these 8 items. In my view, you're well on your way to creating a good AI agent system. I'm going to give you a project for 2 weeks, which you have to build out. So why AI agents? So compelling reasons to use AI agents in the enterprise tech fabric. First is, so the whole question is, we just have caught up with prompts and RAG. And now this new thing has come up. Is it a fad? Is it a reality? Those questions. So obviously, I'm speaking from my experience. And as you know, like with everything cutting edge, opinions are divergent. Right? It diverges from AI agents are nonsense to AI agents are the next big breakthrough after sliced bread. Right? So, but here's how I will put it. Why AI agents? Agentic reasoning patterns work. Simple, practical thing. In engineering, we use something because it works. You use a hammer for a nail because it just works, right? Instead of using a brick, it's better to use a hammer. Common sense, right? So there is accumulating evidence that small LLMs used with the agentic reasoning outperform by many orders of magnitude the bigger LLMs used directly. That is another interesting observation. What people have found is that you have 2 axes. See, the neural scaling law says you want to do a complex task, go get bigger and bigger model. Bigger model means what? More data to train, more parameters, more compute, isn't it? And therefore, you have a bigger model that can reason. But there is an alternative, actually. We are finding that agentic reasoning, by the way, teamwork is the foundation of biological systems. Ants use teamwork, bees use teamwork, bee colonies use teamwork. Humans are teams, organizations. For a reason, because this teamwork works, right? You have the power of collective intelligence, effectively, right? The wisdom of crowds. So you could use much smaller LLMs. In practical terms, what it means is you could use free LLMs that you can actually deploy on your limited hardware, on your 4090s, for example. Mahesh.
When you say they outperform in terms of quality or cost or both?
Both. Think about it this way. You deploy agents, small agents, using a small LLM, but lots of agents. What happens, and you let them reason, increasing evidence that in many situations, not always, but in many situations, the output, the quality of output that you get from the small agents, from small LLMs with the agentic reasoning using teams, multi-agent systems, hands down beats what you would get with a single prompt thrown at a large LLM. Are we together? Right? Now, what is complicating matters these days is, if you look at these frontier models, I suspect, and it's not a suspect, a pretty strong hunch, and that because they don't reveal anything. So we can only conjecture. My conjecture is they have started using agentic reasoning in the background. Like, for example, when you look at O1, there is a significant element of agentic reasoning they are using. So the thing is, if small models can now compete with large models, with agentic system framework, obviously you can get even more power if you create agentic, superimpose it on top of a large model. But when you do superimpose on top of a large model, then comes a problem. The problem is that compute cost gets higher. As you will see, when these agents talk to each other, they collaborate, there are lots and lots of LLM calls. Perhaps that's the reason why you notice that one of these frontier models, the OpenAI guys, they have been proposing that for the latest model which is in preview, when they come out with it, instead of charging you $20 a month, they're going to charge you $2,000 a month. The claim is that that's what the hardware costs. So, well, anyway, we'll see. But this thing, I must tell you guys, if you are using, see, when you have sensitive, confidential data in-house, it would be foolhardy to use a frontier LLM, isn't it? Actually, I don't know whether this is a non sequitur or whether it is relevant, but I'll mention this fact. There was an organization called 23andMe. For many years, people in their infinite wisdom, would send their DNA over to these guys, and they would give you all sorts of information about your Gardner's hereditary, your disease profile, or whatever, blood and the DNA profile. That company is going bankrupt. That company guaranteed you privacy, right? Cross my heart, we will never reveal this, your private medical information, to anyone, to insurance companies, to healthcare companies, etc. That company is going bankrupt, from what I hear. Guess what will happen to that IP? It goes to whoever buys it. Is there any guarantee that your medical information is any more safe after that? Right? So this is the risk with letting sensitive information leave outside a well-contained environment. When there is data exfiltration, all bets are on. Even giants tumble. Who would have thought 10 years ago that 23andMe would tumble? Right? So there, what are the choices? You can't go and download, even if they were to allow you to download GPT-4, which obviously they have no intention to. You would need a massive infrastructure, unaffordable infrastructure to do, right? So your choice is, why not try agentic systems? Especially when I'm telling you that in many, many situations, agentic systems will not only match, but beat it. I've seen it beat it. And I hope that in the project I'll make you do, I will convince you, I'll wean you off the frontier models and convince you that hereafter, you should go with agentic reasoning. Vasanthi.
So these all models, do they need to be specialized or can they be just generally small?
Generic. That's the point. Okay, so guys, I noticed that it's 12:10. Next, more aligned to human teamwork and problem solving. So this is, and by the way, these are my experiences, so take it with a grain of salt. Our ability to work in effective teams, collaborate, and systematically plan and decompose complex tasks into subtasks has come about over hundreds of millions of years of evolution. Would you agree? Right? For example, amoeba is a sole creature swimming in the liquid in a pond. But the fact that organizations of cells formed, multicellular organisms formed, and do that, right there you see the power of organization and teamwork. Our ability to form effective teams, even as tribes, as families, as social units, as corporations, as companies, has evolved literally over millions of years. We have figured out collaboration works and how collaboration works, isn't it? And it is my contention that agentic reasoning piggybacks on the lessons learned from our sociological team dynamics. If you do it right, you can piggyback on basically common sense intuition, which mathematically actually is not common sense. It's it would be pretty hard to quantify. Right. The other reason that I say AI agents is because there is no going back. Once you get accustomed to solving complex problems with AI agents, in this world of LLMs, you will realize there is a sense of inevitability and no going back. Oh, did I just repeat one of the political candidate slogans? One of them is saying, right? What is the exact slogan? We will not go back. Okay, so we will not go back. There you go. It just makes sense to do it this way. Are we together? It just makes sense to do it this way. Rapidly growing enterprise adoption. So while you might not have noticed, can you guess how much money is being poured into AI agentic? People have realized that this is for real. Quietly, can any one of you give me a number? Maybe 10 million a year, 100 million a year. How much is being invested globally into AI agent systems?
Can be.
Yes, you're closer to it. Actually, the number is somewhere between 10 billion and 100 billion. So there is a vast, quiet momentum. It's like a tidal wave in what people want to do with agentic systems. huge momentum. It's a big tsunami coming, right? And guys, I suppose it's about vectors. There are many things we try to give you over the years, but if there is one thing that I feel a little bit proud of, justifiably or unjustifiably, is that we have always managed to teach you things that are ahead of the curve. We have managed to teach you things that are coming, the waves, the big tidal waves that are coming. This is coming, guys. When it is not just academic talk, when people are pouring real money, billions into it, this is real. It is happening on factory floors. It is happening in industrial settings. It's happening everywhere. A box falls down on a shop floor. Accident happens. Our agentic system reasons, what should it do? Picks it up, gives it to the right other agent to handle it and figure out where to put it, and so on and so forth. A part failure happens. One agent determines that this part is defective. Another agent determines whether it should be like the degree of defect and what is the fate of that part, and so on and so forth. These things are being done as we speak. These systems are being built as we speak, and the momentum is enormous. Right? So where are they used? Well, common sense situations. Let's look at some easy practical situations, some practical use cases to which LLM-based AI agents have been harnessed. Easy one, no-brainer. Personalized customer support. So multiple agents can handle different aspects of customer queries, such as troubleshooting, product recommendations, feedback collection, coordination to deliver a seamless support experience. So when people, let's say that you're trying to repair a TV or something like that, or computer, it takes, have you ever had the situation of being transferred from here to there to there? We all have that. But with multi-agent system, what can you do? A multi-agent system is behind a human being, right? Giving the perfect guidance to the human being by looking into let's say the customer support aspect, sales aspect, and many, many other aspects, and helping creating a high impact customer experience, right? Enhance customer satisfaction, reduces response time, and scales support operation efficiency. Do you see that, guys? How it changes the dynamic? You're not removing the human, but you're empowering the human, right? And human becomes one agent in a multi-agent system. Do you see that, right? Human is part of the team, multi-agent system team, that together has a common goal, give the highest support to the customer. Another thing, collaborative complex content generation. Let's take a use case, a research paper. Research paper is written by people who have good writing skills, people who have done the actual work, the method, and different people have done different parts of the experiment or the paper, experiments in the paper. They have different data to contribute. Somebody is very good with the background. Professor will come in and say, okay, no, I need to write the introduction and refer to this paper and that, and so forth. Research papers are collaborative efforts, writing of it too. And you can do that. Marketing material, no brainer. People are using agentic. By the way, you guys will do that. Okay. Business plans. Did you guys build a business plan in this course, prompt? You did, right? Did you make a business plan for your ice cream? In this course, prompt course.
Instructor.
Using the instructor. You did that, right? President's confused because he's in both the courses. Yeah. So you're getting lower. So, okay. Creative writing, right? And each agent can specialize in drafting, editing, fact-checking, or ensuring coherence and style consistency. Wasn't?
Yeah, so I was just listening to an NPR talk about universities saying this is wrong, right? They want they only want the human interaction, and they think that this is plagiarism and you should reduce it out. So do you think that this will slowly change this?
See, that is a very good question you raised, which is about the copyright aspect of it. When AIs create marketing material, to what extent are they plagiarizing? And that question is a thorny lead. I completely agree. For example, for the longest time, the AI community argued that our models don't memorize. We are not stealing. We are not plagiarizing. All that our models are weights and biases, floating point numbers. How can they possibly be plagiarizing? They're just predicting the next probable token, right? They're stochastic patterns. New York Times came forward and says, okay, if that is true, explain to us. It's a black box. We give it one sentence and we ask it to continue, and it exactly reproduces a New York Times article. So why is this not plagiarism? And they are right. And so the big question that is there with all of these systems is, to what extent there is copyright violation? I believe the answer is not in this debate. Always, when you're sitting on the horns of a dilemma and two opposite sides argue effectively, the answer is that you have to look a little bit deeper. Now, with a little bit of a background with jurisprudence, here's what I will say. Copyright laws and patent laws were created around 1200 AD. They were created by the Dutch merchants who created the idea of the corporation. And feudal lords had land property, tangible land, they call theirs. But as inventions began to come, they needed to protect the inventors, the effort of the inventors. They created patents and copyrights. Well, 900 years have passed, right? 800 years have passed now, 900 years. It is time to rethink those laws in the context of this AI. Many laws, many things will have to be rethought. It is time for jurisprudence to think deeply on this topic and update what is the boundary that we need to put. Ultimately, what we can say is copyrights as we know it are antiquated now. We need to think, how do we protect the rights of the inventor, the creative? How do we protect the efforts of the creative in the world of AI while still letting, see, you give something with something in return. The copyright law said that it is copyrighted. Nobody can plagiarize your work for 100 years. So long as you let people quote your work 1 or 2 paragraphs at a time, or 1 or 2 pages at a time, right? That was called fair use. You reciprocate with fair use, allowing a fair use, you get the right to that content, copyright to that content, right? So that was the copyright law, and plagiarism was exceeding fair use, right? Unfair use was plagiarism. I believe we need to really think it up. But here's what I would suggest. The point is valid, and people have been talking about it. It's a debate. My own perspective is, have an agent and have a tool that does a plagiarism check. Make sure that the content you generate is not plagiarized, right? There are tools, actual plagiarism tools, that will tell you if any piece of content shows disturbing similarity to known work, right? You pay a few pennies for that, using those tools, or $1 or $2, but use that, just have it there. If you create marketing literature, make sure that. Now, here is a study that came out recently. AI-generated marketing material is proving to be more persuasive and more effective than human-generated marketing material. It's a real study. It is one reason sales and marketing, there's a real danger that those guys may go through a massive job displacement. The nature of their job will have to change. They'll have to do something different from what they're doing today. But yes, I don't know if I did answer your question, but that's where it is, right? And to me, I don't know, anybody with a background in jurisprudence. See, as you think about copyright and patent, I would strongly encourage this whole question. What is rights? We talk about copyright and plagiarism, right? I'll take a very minor digression. What is right? What are my rights? Every society has a different notion of rights. I have a right to free speech in the United States of America. In different countries, you don't have a right to free speech. In most countries, and I think to some extent in US also, though we don't admit it, you have a right to free speech, so long as your speech agrees with the powers that be, right? So long as the powers that be are happy hearing you. But the moment you start saying things that they don't like, they find unpleasant, then to different degrees, and I think US is still one of the freest societies where you can get away by saying, disagreeing with the authorities quite a bit. But in most other countries, there are pretty severe consequences. Right? And there are actually government sides. So rights are a societal consensus. What do you value? In this country, we value freedom of expression, right? So we enshrine it as an important right. Also, we enshrine the right to bear arms. In many countries, in India, for example, you don't have a right to bear arms. In Europe, you don't have a right to bear arms. Japan, you don't have a right to bear arms. Right? You need a very, very specific license and a reason to bear arms in those countries. Right? So rights reflect the social values of a group. Rights are not God-given. They don't fall off the sky, or we are not born with them. And they are a societal construct. And for every right that you get, you give something in return. You give up some freedoms. For example, you have a right to free speech, but you don't have a right to randomly chop off the head of the next guy you disagree with. Right? So there are certain norms and responsibilities and laws that you have, constraints that you have to agree to. And so that is something that will evolve. I don't know, it's a digression. And it goes to the heart of jurisprudence. And for example, what do you have a right to? If I dig under my soil and I find gold, is that gold mine? Every society has a rule. In the United States, I believe it's 70 feet. Anything you find within 70 feet is yours. Anything deeper than 70 feet is the government's. So if you find oil, keep hoping is well, I don't know what the real law there is, because law is oil is a complicated business. But
Something like, the rights, when airplanes fly over your territory, you have to pay that country, right, for the right to.
that is right.
But satellites don't have to pay that. So
Yeah,
beyond
exactly. They're
the
far
line,
off. Yeah.
That right goes in.
Yeah. So anyway, moving forward, collaborative complex content generation is that. And content generation is contentious, Vasanthi, I do agree with you. Virtual teaching assistants. Literally, you will see it here in this classroom. There is a virtual Asif, speaks like me, talks like me, right? Has read up all my lectures. At this moment it's offline, I'll bring it online. Actually, that was the first project of the first batch of LLM1. Build that virtual Asif. Actually, I'll have Hamad demo it. So this is it. What's the advantage of that? You have access to high quality knowledge all the time. If you can drag all the knowledge, all the lectures of a professor, all the knowledge of a subject, do you realize that you have unlimited access to teaching assistants? It makes health and wellness coach. One of the problems with health is you go to every specialist and the recommendations are different, and some recommendations contradict each other. With a good multi-agent system, you can have a collaborative, all of them coming and agreeing on a plan of wellness, plan of action for you. If you remember Mayo Clinic and Cleveland Clinic, that was the innovation. Why is it that they have such a high success rate? Doctors are everywhere. The reason they have that is they innovated this. They said that, see, we will not send a patient from specialist to specialist, bounce him around. Instead, what we will do is a patient comes into our clinic. We will all look at the patient. Then together, we will get into a room, meet. Together, we'll come up with a plan of action for the patient across all the specializations and recommend that as humans. That was the innovation. And because of that innovation, they support or they sustain the world's highest quality of medical service. Right? In a country where medical service is nearly a train wreck, healthcare is a train wreck in this country. Nevertheless, these clinics are supporting the highest level of service and success rates and outcomes. The same thing applies. You know, that thing can be transported to AI agents. You can't do that Because why are other hospitals not doing it? Can you guess? Profit motive. It's not economically viable for them, right? They want to provide the service at the lowest cost possible and charge you the highest amount possible. Maximize profit margin. Healthcare is a business controlled by, in this country at least, by Wall Street. Right? But what you can do, and what even those Wall Street people can be convinced of easily, is that let's use multi-agent reasoning systems. Right? If humans are too expensive, let's bring AI that will do that job. Supply chain optimization, and so on and so forth, urban planning, city planning. You can have specialists for sewage, you can have specialists for water supply, you can have specialists for electricity, for telecom, and so forth, right? Robotics and industrial automation is happening. That is where AI agent systems are being most adopted. Military and defense application, no brainer. The next war, there is a very influential report that came out. I don't know if many of you have read it. It was called Situational Awareness. It was written by an ex-OpenAI guy about the potential perils of AI. And he made a very interesting statement. He said that a best case situation is there will be an AI arms race, AI race between the superpowers, whoever they are, US, China, etc. Right? The worst case situation is there will be a full-blown AI war, which will be fought with AI agents.
Like the opening scene of T2.
Yeah. So guys, these things are not hypotheticals. The military of every single country that I know of, superpower, they are writing blank checks. US, and I happen to know that in US, literally, you do a startup and you say you're going to use AI agent swarms to do this, that for defense, you will immediately invoke interest. And I believe every country must be doing the same thing. They're practically at this moment, massive investment in this. So we talk about LLM agents. I will be brief. We covered this paper, generative agents. Do you remember that? Or not? Did I cover this paper? Okay, we did not. So I'm going to give you, well, obviously you did, right? Yeah, we did. So what was it about? Each of the agents was a prompt, isn't it? We live in the world of LLM agents as prompts. LLM agents are what? Each agent has a prompt, a backstory, etc., a life that it's living. It managed to recreate human behavior. By the way, this paper has garnered how many citations? It came out in, spring 2012? No, 2022. Sorry, I apologize. 2022 or 2023? Spring 2023. This paper, so this date is wrong. Yeah, look at this. It came out in spring 2023. Revised version was in August 2023. It's just a year old, a year and a half old. Can you guess how many citations has this paper commanded? 100, 200?
1,000. There on the screen.
Oh, no, that is,
Okay. It's checking if people are reading this.
yeah, generative agents. So let me show you this paper. Let's see what the situation today is. It's growing, 1,054, right? So for a paper that is a little more than a year old, isn't it astounding that it has 1,054 other research papers have referred to it? What does it give you a clue of? First of all, at least 1,054 more papers have been published in agents. Actually, the number of one of the hottest areas of research at this moment is agents. And this paper is remarkable. I cover it in the very seriously in the agent course. I won't be covering it here. But basically, what shocked people is that these autonomous agents living their life, one is a chemist, one is a professor, one is a student, college student. They're living their life in this little village. And one is standing up to be the mayor, one is people are talking, they're having conversations. People are changing political views based on the discourse. You see the effectiveness of gossip, right? How gossip spreads. Like gossip is the communication spreads, diffuses across in diffusion of information, right? And you see emergent behaviors. One of them realizes that Valentine's Day is coming, throws a Valentine's Day party. People start proposing and finding dates. They all spontaneously show up for the dates, Valentine's Day party with their dates. Can you imagine? None of it was programmed. But this behavior spontaneously emerges. Remember, I talked about emergent behavior in multi-agent systems. You literally see, and by the way, they just worked with a very small number of agents, I believe 24 agents. Today, people have redone these things with thousands of agents with remarkable results. This field is growing. So let us summarize what we learned. Well, obviously, you haven't done this paper. What is it that we learned? So in that paper, we already see the key ingredients of successful multi-agent collaboration. I'll just give you the narrative of that. So here are the key qualities of a good agent. Each agent knows, who am I? Okay. Who am I seems to be the perennial question in Indian philosophy. All right. Who am I? Observe for each LLM agent the following things. Clearly articulated focus role. This is a chemist. This is a college student. This is a guy standing to be the mayor. They have clear roles, clear personalities, right? So here is one way that I would say it. See, LLMs have mastered all the knowledge in the world that is there, right? They are like 1,000 PhDs behind a curtain. An agent is invoking one personality to step forward. Are we together? The LLM to become one of the thousands of personalities that it could possibly be. And that LLM will now play that role. And by the way, this is very, very effective. You will see in experiments, if you were to do the agentic code, you ask an agent, you make an LLM into a creative writer, writing stories or poems and so forth. And you give it a math problem and it will dimmer. It will say, I don't know if I can solve it, but here is my attempt. And to another agent, using the same LLM, you say, you are a high caliber mathematician, solve this problem. And it will say, of course, here's the solution. You see the distinction, right? Same LLM is responding differently, picking up different roles, different personalities. So you need to have clearly articulated focus roles, have a personality and a background story, have access to a memory stream. You need to have memory. You can't have a person. See, personalities are contingent upon memories. One of the oldest thoughts in many philosophies is that our sense of identity is nothing but a stream of memory. I don't know if you know. It's often speculated. So you need an access to a memory stream. Capacity for reflection and critique, of course, no brainer. You do need the intelligence and ability to self-reflect and so forth. Rules of engagement with other agents. You should know, if I'm in this role, what does it mean with my interaction with the other agent? If I'm a nurse, what's my interaction with the physician? Right? If I'm the sailor in a ship, what's my interaction with the captain? So for example, if I'm the, let's say, engineer on the ship, and what's my interaction with the captain? For example, if one of the engines fails, who is it that I should tell? Should I tell the captain? Should I not tell the captain? Basic decision, right? How would an LLM know? Because you imbue it with that personality. It knows the rules of engagement. Again, he's talking about that paper, agentic behavior, views and actions. Observe the setup of small village, a sim like small village. So in other words, you have to not only create the agents, but the agents are in an environment. Are we together? They engage with an environment. You have to situate them within the environment. You need to carefully articulate the environment. You do that, the libraries, schools, playgrounds. They show emergent societal behavior, surprisingly successful simulacra. What are the open source agentic framework? The earliest one, and perhaps with the greatest number of hits, is the AutoGPT, a great place to start. Given its intuitiveness, you can play around with it yourself. It has over 166,000 stars on GPT. Very easy to get started. Personally, it doesn't meet my definition of agentic reasoning, which I think is multi-agent system, because there's no team, there's one agent. I think they're trying to introduce teams, but I don't know where they are. Have they done it or not?
Today, I'll guide you through.
Okay, so look at this. It is so
Today,
easy.
I'll guide you through setting up and running the AutoGPT server and builder. This tutorial will cover downloading the necessary files, setting up the server, and testing the system. Navigate to the AutoGPT GitHub repository. Click the code button, then select download zip. Once downloaded, extract the zip file. Open the extracted folder and navigate to the R&D directory. Enter the AutoGPT server folder. Open a terminal window in this directory. Open the README file. Copy and paste each command from the README into your terminal. Wait for each command to finish before running the next one. All commands run without errors. Enter the final command, poetry run app. You should now see the server running in your terminal. Navigate back to the R&D folder. Open the AutoGPT builder folder. Open the README file in this folder. In your terminal, run the following commands: npm install, npm run dev. Once the front end is running, click the link to navigate to localhost 3000. Click on the build option. Add a few blocks to test the functionality. Connect the blocks together and click run. Check your terminal window. You should see that the server has received the request, is processing it, and has executed it. And there you have it. You successfully set up and tested AutoGPT.
So look at this. What are they using? You see that these are just tools that they are using, blocks and tools that the GPT is using. Now, in this particular case, they use GPT as the main brain, and it's a single agent system, single agent using many tools, which is why I don't particularly emphasize this. This is the one that I like because it allows you for multi-agent, a full team creation. So this is multi-agent collaboration. You use that. Autogen is another. There are many other, but for reasons that Llama agent is, it would be hard to find a person who is not busy creating his own AI agent or her own AI agent system these days. Everybody seems to be doing that. Right? So, but we will standardize on Crew AI. Right? So the way the Crew AI works, and in the afternoon, we will do that. I'll skip that. I will now bring Crew AI website here. I want you to do this. Is there cute that way? AI. CrewAI.com. Go there. Now, here is a task I'll give you. Today, you are going to master Crew AI, and here is a project that you will do. You'll do two projects, right? First project is a small one. It is a show and tell, like do whatever you want, but create something that is best achieved with agents and cannot be done with a single prompt. Are we together? Do something, or cannot be done as efficiently with a single prompt. I'll leave it to you and to your creativity to come up with an idea. You need to present it at 5 o'clock. Or 4 o'clock, actually 4 o'clock, because I want to read a paper after that for you. But here is something that I'll give you as a 2-week project. So we'll take a 2-week hiatus. We won't cover any new topics. I want you guys to just do this. Everyone. Prasanna, you do. So just for your reference, Prasanna has taken the AI agent course. So for him, it will be easy. So you can be the guide and mentor. I suppose people will reach out to you for help. But anyway, as you do this project, remember, you have access to 7 teaching assistants besides me. That's our team of 8. You can reach out to us, we'll help you. We can show you a solution. Here is your project that you have to do. I want you to use news aggregator APIs that are available out there. Search APIs that are, search tools that are out there. So for example, there are lots of tools like Serper and so on and so forth that can help you search the web, right? Search the web. There are Wikipedia tools that will help you search specifically into Wikipedia. There are RAG tools that will help you search your document base. Are we together? And there are specific news tools. For example, Reuters, you can go and take an, if you have a license, you can go and get the news specifically from them. And there are many other commercial tools. Pick yours, but I want you to do this. I want you to create a website, a high quality website, which is a news website on AI, which will have a main page, which is the headline news. Think of New York Times, headline news. I'm a New York Times for AI. It will have headline news. Then it will have a page dedicated. In the headline news, there'll be little areas for the core headline items. Then there will be sections for natural language processing, for computer vision, for multimodal learning, for a big 5-6 topics in AI. It will have that. That news page should be deeply imbued with many qualities, including graph visualization. All the important, first of all, there should be a word cloud on the main page showing exactly what's the buzz at this moment. Then within NLP, within computer vision, again, based on the latest works, what's the buzz? Latest work should include research papers as well as emerging open source projects. Are we together? Your news site must have a glossary. So imagine that I'm a user, I come to your site, I hear about this great breakthrough on multi-agent collaboration. I have no idea what an agent is. So the word agent should be hyperlinked to a glossary. The glossary of all the terms, right? A rich glossary. Your news site should update every day. Does that look something we can build? Let's break it up into parts. First of all, let's do a minimal viable product, right? So your first release. Right? What could it do? You could just search the web, look at the headline news on each topic, right? And gather the top news items. Just create your own news by just harvesting the news. That's easy, right? All you're doing is classifying this news belongs to computer vision, this belongs to NLP, this belongs to multimodal learning. Am I making sense? Your different themes, classify it. You can therefore create a little homepage with these news sections. And then the drill down pages would be exactly that. How do you create a word cloud? Very easy. They are word cloud tools. Just a 2-liner in Python to create a word cloud. You can do that. You can create an interactive graph, but let's start with just a simple word cloud, right? So can you create a newspaper that this tool, which fires up every midnight and runs and recreates a page? Of course you can, right? But make it better, make it usable. How do you create a glossary? Of course, you should, I think you have been through that exercise of creating a glossary, isn't it? Create a glossary. How do you hyperlink from the pages that you create to the glossary? Very easy. Just find every string, every keyword in your glossary, and wherever you find it in the text, make it into a hyperlink. Am I making sense? Right? So guys, you can do it, but the thing is, how well can you do it? And how well can you host it and make it a useful site? Remember to pick up the sources of news are, what are the good sources of news in AI? Obviously, you can search the web, Twitter, social media. Twitter, there are specific Twitter channels which are very good. There are specific Reddit channels which are very good. For example, Local Llama is very good. Reddit has an API you can use as a tool. YouTube, you can look, you could be listening to specific channels which are very good with AI news. So you could be really creative and you can do that. So I'll give it to you as a 2-week project to build this out. Now, here's the thing. This is your first interaction with AI agents. So keep it simple, keep it light, don't go too deep. Later on, when you come to the AI agents class, you will do it in a far more deeper way, but give it your best attempt. It is important because this would be a good segue and a bridge to RAG, which we will do. And I would like to give, like we have been learning a lot of new topics continually. I wanted to keep 2 weeks. Is it okay, by the way, guys? I want some show of hands. Is it okay if we give 2 weeks dedicatedly to doing a capstone project with prompts and prompts with a touch of agents, just a small touch of agents, not necessarily very deep agents. And if you don't want to use agents, that is fine. If you want to do it just with prompts, do it just with prompts. You don't have to use agents. Are we together? But go do this capstone project. But today's homework, which you'll show at 5 o'clock, do something that you like with AI agents. Are we together? Now, to do that, there is a little course that I want you guys to take. Go to this website, Deep Learning .ai. When you go, oh, by the way, look at this. They have a newsletter called The Batch, right? See if you can produce something of this quality. That's a very high bar, nothing like this, but there should be a good template, right? For you to do that. But this is hard to do. It's not that easy with just agents. But in this, you will see some short courses. One of the courses is on Crew. Do you see this short course, multi-AI agent systems with Crew AI? So guys, this is a very good course specific to Crew. And you will notice that the points that I'm making, and you'll see why I like Crew AI, it aligns with my way of reasoning. Each agent is specialized, has a role that defines it, has a goal that you give to it, has access to tools, and has a backstory. Now, the way they do it is very basic. When you do it, I expect you to do a full-blown proper prompting because there's 70. So in other words, when you do your solution, do it far better than in the tutorial. Make sure that you follow the full, for example, the CoStar or something like that template. Right? Make your agents far more well described and carefully created. Make sense, guys? And take this course. After that, build something by 5 o'clock. That is it. It will take you an hour and a half to do the course. It will take you an hour and a half to do your project. Go ahead, Mahesh.
Just went to Crew AI. Even the free trial, it's on a wait list.
No. That's for the enterprise version. Go to Creo AI GitHub. Sorry, I should have said that. GitHub. Go straight here. It's an open source. Go with the open source, guys. Don't go with the commercial. Right? Read the documentation, get started. There's absolutely no paying business here. You pay if you deploy your Creo, your entire multi-agent system onto their cloud. Why would you want to do that? There's no reason to. Not at least for academic purposes when you're learning. So. All right, guys. So with that, I'll stop the recording.